Hi, this is Mrs. Vrobel. This is Chapter 9, Chemical Reactions, Part 3. So in this video, we're going to learn about what is an aqueous solution, and then we're going to look at what is a complete ionic and net ionic equation when we're looking at reactions in aqueous solution. And lastly, we're going to look at the reactions, whether or not they produce a precipitate, a liquid water, or a gas. So in aqueous solutions, please remember that it typically is a dissolved substance in water. And when we classify a solvent, it typically is a substance that is more plentiful than the actual solute. Now, if you were to look at water, now notice if I take some salt and I sprinkle it into the water, a couple different things are going on. We're actually having the salt that I put in the water separate out into ions. So it's in a crystalline form before I add it to the water, but the moment I put it in the water molecules are pulling the different ions apart, and as a result they become dissolved, or they go into the liquid phase. This is what we call dissociation. So you have a crystalline form of repeating sodium and chlorine ions. The moment you put them in water, the water molecules separate them out, and we call this dissociation. Here's a picture of what's going on. Notice that the water molecules, they are attracted to the opposite charges, and as a result they essentially are pulling these ions out and they're surrounding them. So when you have all of the water molecules surrounding an individual ion, that puts them in the liquid phase. And notice that the positively charged hydrogen is attracted to the negatively charged chlorine. And the opposite happens with the sodium ion. So two solutions, if they contain ions as solutes, these ions might react. Now, if they do react, this is what we call a double replacement reaction. And like I said before, you can have formation of a precipitate, liquid water, or a gas. So here's an example of sodium hydroxide, and we have copper 2 chloride dissolved in water, and as a result they form a precipitate. So it would be written like this, and notice that there's AQ written after each compound. However, if you look at the precipitate, it has an S at the end. So if it's a precipitate, it will not be in the aqueous phase. Now, you could actually take this equation and break it down into the individual ions. And you might want to notice the fact that anything that is dissolved or has an AQ after it, we can separate it out into ions. However, the precipitate, we cannot. So the precipitate we're going to write as a chemical formula, not an ionic formula. The way you know that there's an ionic formula is if you have a plus or a minus sign written after the element symbol. Now, there are ions that actually do not participate in a reaction, and we call those spectator ions. So like going to a football or a basketball game, you're not actually involved in the game, you're just watching it. And spectator ions do the same thing. They just watch the other ions react with each other. So here we have a number of compounds, or I should say elements, that are not participating. So sodium, I'm going to cross it off because it appears the same way on both sides of the arrow. And I'm going to separate out chlorine. Notice that it appears on both sides of the arrow. However, I have OH minus and copper 2 plus. They do not appear on both sides of the arrow. And I have copper hydroxide, which is different on the other side of the arrow. So the overall equation that we call net ionic, it does not contain repeating elements on either side. So that's how we figure out what the net ionic equation is. Here's a water reaction. So I've done the 3 steps here, and the first part of it is called the molecular. So molecular, you're going to write out the whole formula, and notice there's AQ after every compound except water. Water has a liquid symbol because that's our product out of the double replacement reaction. With complete ionic, we're essentially taking the individual ions and breaking them down if they're considered aqueous. So notice how I have lithium and hydroxide over here. And then I want to also take anything that's aqueous on the product side and put that over on the product side. And notice that I rewrite water because I can't break that down. Now I'm going to cross off anything that repeats itself on either side of the equation. And as a result, I should be left with 2 hydrogen, water, and hydroxide. That is considered the net ionic equation. The last type is gas. You're doing the same thing. So once again, I'm going to write the molecular equation, and that includes everything with an AQ after it. Notice that the gas itself has a G. Once again, I'm going to break it down into ions if there's an AQ after the chemical formula. And then I'm going to cross out anything that repeats itself. So sodium appears on both sides. And chlorine appears on both sides. So that overall I have 2 hydrogen, a sulfur, sorry I'm getting a little messy here, and hydrogen sulfide. So that is the net ionic equation. Okay, so in summary, when we're looking at aqueous solution, the solution will always contain water. With molecular compounds, when they go into the solution, they typically separate out into ions. Now, we have ions that actually will participate in a reaction, and there's those that do not. The ones that do not, we call those spectator ions. Please note also that the solvent molecules typically are not involved in the reaction. These type of reactions that occur in aqueous solution, we call them double replacement reactions.